A vector has the components a sub x is 22 meters and a sub y is 13 meters. A, what is the magnitude of this vector? And B, what angle does this vector make with the positive x-axis? So let's draw an axis. And then draw our vector, or at least its components. It has ax equals 22 meters, so this is 22 meters. And ay is 13, so make it a little bit shorter. It doesn't have to be to scale, but it's nice if it's in roughly the right shape. And what we're looking for is this. That's A. And then I guess in part B, we're looking for that, knowing it's, by definition, a right angle. And then it's relatively straightforward. We say A is ax squared plus ay squared square rooted, which is just the Pythagorean relation among the sides of that triangle. So we get the square root of 22 meters square plus 13 meters square, all under the radical, and we end up with 25.55, but I only have 2 sig figs, so I guess I should call that 26 meters. And then the other half of the game is to say that the tangent of the angle, which is the opposite over the adjacent, and then this is the opposite side, and this is the adjacent side, so we end up with ay over ax, and then we have our theta is sort of trapped inside of tangent, so we invoke the inverse tangent function, and we say the inverse tangent of the tangent here, and we do that because the inverse tangent of a tangent sort of magically produces the angle. But we also know from algebra that anything we do to one side, we have to do to the other side. So we also have the inverse tangent of ay over ax. So theta is the inverse tangent of ay over ax. That is the inverse tangent of 13 meters over 22 meters. Really quick aside, inverse tangent needs to eat a dimensionless number because angles, because we're taking the inverse of a dimensionless ratio. So we check here, meters over meters works out. But as general, we should always try and make sure to check that the units go away. If we throw this to a calculator, we get just about 30.6 degrees. So do 2 sig figs, I guess you'd call that 31 degrees. Although to be honest, sig figs are a little strange for trig functions. But there we go. There is sort of a minor possible complication that didn't happen here, but you should be careful if you end up having to, if your components have signs that aren't positive. But here they're both positive, so life was easy.